Now let's look at composite shapes. So, and how perimeter applies to that. A composite shape is a shape that is made up of, it's a figure made up of multiple figures. So it's when you're figuring out area or perimeter, you use the respective measures and formulas that go with those kinds of shapes. So let's just dive into a couple of these, and I think intuitively you'll kind of get what to do right away. So find the perimeter of this figure, round to the nearest tenth. So if I look at this figure, I got to make a couple connections. The first connection I got to make is it looks like I am dealing with a rectangle, that this piece right here is a rectangle, right? So that's a rectangle. What's useful about that, if this is a rectangle, that means that while this side is 3.5, that this side also is 3.5. All right, and then if I needed this side right here, it would be 2.4. But I don't need it. It's not important to this because it's not on the outside of the shape. All right, and then the next thing I got to recognize is, I'll change colors here, is that this 2 also applies to this right here. And then at that point, you should be able to look at that and say, oh, well, I've got everything I need. So I'm going to go 2.4, and I'm going to add it to 3.5, and then I got my blue 3.5 up there, right? So plus 3.5, and then I've got my 2 plus 2.0, and then I've got my red 2. All right, that's why I color coded it. It's kind of a pain in the neck to do this, but that's why we do it. And then you just add everything, right? That's all you do. So 2 and 2 gives me 4, and I can drop the 0.0 because I don't need it. 3.5 and 3.5 gives me 7, right? And then 2.4 is just 2.4. 7 and 4 give me 11, and then 11 and 2.4 give me 13.4, and then my unit would be centimeters. So we have 13.4 centimeters, and that's really all there is to these problems. All right, let's look at this one here. So this one, I want to look at what the exact outside shape is. So it's this part right here, which I know is 3, and then it's going to be this little bit, which is going to be half of the circumference of what would be this full circle if we had the whole thing, right? We don't, so we can get rid of that. But if we did, that's how we would figure out. So what we got to do is we got to recognize that, well, I'm assuming this 4 meters is the diameter of this circle. So the radius, right, would be this, which is half of that, which is 2. All right, so we'll need that in a minute. And then we finish and we come around and then we wind up where we started, which was right there. So we're going to have 3 plus 5 plus whatever our half circumference is. So let's figure that out. All right, so I know circumference is 2 times pi times r. So 2 times pi, and then my r is 2, so it's 4 pi. And then I know it's going to be half of that. So I'll take half of 4 pi is 2 pi. And then we grab the calculator and go 2 times pi equal to 6.3. Because I believe they also said to do tenths. And so we got 6.3. All right, put that in here and then just add them up. 8 plus 6.3, well, 8 plus 6 is 14, so we have 14.3, and then meters. And that seems pretty reasonable, right? I could see this being about 6, right? That makes sense. It looks like it would be longer than this. So that's really all there is to these kinds of problems. It's just a matter of breaking everything down and using what you need. So good luck.